Hey there, welcome to Math That Actually Scores. I'm LeBron, and today we're talking about vectors, and I promise this is actually going to be useful and kind of fire, just like my step back three. So what's a vector? Imagine regular numbers, right? They're basic, just size. 23 is bigger than 6. Cool, whatever. But vectors are built different. They have size and direction. They're like the upgraded premium version of numbers, like going from high school straight to the NBA. Think about it this way. If I tell my teammate run 15 feet, that's not super helpful. 15 feet, which way? But if I say cut 15 feet, to the baseline. Now they know exactly where to go. That second instruction is a vector, magnitude plus direction. Boom. That's how we run plays on the court. Vectors show up literally everywhere. When I'm making that perfect assist, I'm calculating vectors. That crossover that breaks ankles, vectors. The arc on my free throw, vectors again. My trainers are obsessed with vectors because things like speed, force, and acceleration need direction to make sense, just like when I'm chasing down a block. So how do we actually write these vectors? The easiest way is using components in 2 dimensions, like on a basketball court. We write them like 3, 4. That means move 3 units right and 4 units up. It's like court coordinates, but cooler because they represent movement. If you're in 3D space, like when I'm elevating for a dunk, you just add another number. 3, 4, 2 means go 3 right, 4 up, and 2 forward. Video games use these all day long to track where everything is moving, including my character in NBA 2K. The length of a vector, how far it actually takes you, uses the Pythagorean theorem. For a vector 3, 4, the length is square root of 3 squared plus 4 squared, which is square root of 9 plus 16, which is square root of 25, which is 5. See, that geometry class is finally paying off, just like all those hours in the gym. Now for the fun part, vector operations, adding vectors is unhinged easy. If vector v is 3, 1 and vector w is 2, 4, then v plus w equals 5, 5. You literally just add the matching parts. It's like how my points and assists add up to make my overall stat line. Subtraction. Same energy, just subtract 3, 1 minus 2, 4 equals 1, negative 3. You can visualize subtraction as finding the vector that gets you from the second vector to the first one, like calculating the perfect passing lane between defenders. Want to make a vector longer or shorter, but keep it pointing the same way. Multiply it by a regular number, double it, twice as long. Half it, half as long. Multiply by -1, complete 180. Now it's pointing the opposite direction. It's like adjusting the power on my jump shot, depending on distance. More power from downtown, less when I'm in the paint. Now let's get spicy with the dot product. This is a way to multiply vectors that gives you a single number instead of another vector, and is actually cracked. For vectors all 1, v2 and w1, w2, the dot product is v1 times w1 plus v2 times w2. For example, 3, 4 dot 2, 1 equals 3 times 2 plus 4 times 1, which is 6 plus 4, which equals 10. The dot product is low-key magical because it tells you about the alignment of vectors. If the result is positive, they're pointing in roughly the same direction, like me and my teammates all moving toward the basket. If it's 0, they're perpendicular, making a perfect 90-degree angle, like a proper defensive stance. If it's negative, they're pointing in opposite directions, like when I'm playing defense against an opponent. This shows up everywhere from calculating work in physics to how coaches analyze player movement patterns on the court. No cap, the dot product is basically telling if 2 things are similar or different. So why should you care about all this? Because vectors aren't just a school thing, they're the whole future of the game. The most fire technologies in basketball all use vectors. Player tracking systems, just spicy vectors finding patterns in movement. Basketball video games, vectors rendering 3D courts and players. Those highlight reels with cool graphics. Vectors transforming the footage. Advanced stats that scouts use. Super abstract vectors in wild dimensions. The app showing you the best route to the arena. Vectors calculating the fastest way to see me play. As you level up in math, you'll see more vector concepts, vector spaces, transformations, eigenvalues, all built on these basics we just covered. Vector calculus will let you analyze biomechanics, optimal shooting form, and other stuff that makes sports scientists go crazy. Even the algorithms that calculate my player efficiency rating use vector operations built different for speed. Learning vectors now is like getting cheat codes for your future, just like how I study film to improve my game. So that's vectors in 5 minutes. They have magnitude and direction. You write them with components. You can add, subtract, and multiply them. And dot product tells you how vectors align. Vectors are literally the backbone of modern basketball analytics science and basically everything cool. Remember, regular numbers are mid. Vectors are goated, just like championship rings. Thanks for coming to my TED Talk.